Okay, graphing lesson part 2. So we're going to graph by plotting points and by using our graphing calculator. So let's determine whether each equation has the given ordered pair. So we're going to take this ordered pair, and we have an x and a y, right? And we're going to plug it into the equation, or substitute to the equation. So we're going to say 2 equals 3 times x, which is 0, plus 2. And we're just going to see, does this satisfy it? Sure, it gives 3 times 0 is 0, and I get 2 equals 2. So that checks out. So yes. How about part B? Part B, we're going to say 2 times, again, there's our x and there's our y, 2 times 2 minus 3 times 1. Is that equal to 6? Well, 2 times 2 is 4 minus 3. That is definitely not equal to 6. 4 minus 3 is 1. So this one was no. So where this is important is that if a point satisfies this equation, that means that point lies on that equation's line. We learned earlier this is an equation of a line, or it's a graph of a line. So when we have this ordered pair 0, 2, that means, and it satisfies it, that means that point necessarily lies on that line. So given that equation, y equals 3x plus 2, let's verify that these two are indeed solutions. We'll call it xy and xy. We've already done the first one, right? Let's do the second one. So y, which is 8, equals 3 times 2 plus 2. Does 8 equal to, what's that, 6 plus 2, which is 8? Sure, 8 equals 8. So we verified both of these are solutions. Now let's plot these points and draw a line through it. And now let's see if we can use our line to determine a third point. Sure. So we have here 1, 5. It's another obvious point. You want to pick a point that crosses through a grid point. Okay, try this one on your own. So given an equation in two ordered pairs, show that each is a solution, and then graph, and use the graph to find another solution. All right, welcome back. So we have x, y, x, and y. So when I plug a 0 in for x and a negative 2 in for y, I'm going to get 2 times 0. Forgot I'd already typed this out. So we have 2 times 0 minus 3 times negative 2. Is that equal to 6? Sure. Negative 3 times negative 2 is 6. Do the same thing with the other one. 2 times 3 minus 3 times 0, 6, and 6 equals 6. So once we know that there are solutions, we plot those points and we draw a line, and then we can go ahead and use that line to find another solution. This point here looks pretty good at 6, 2. So again, ordered pairs and linear equations. So what are some ordered pairs that would satisfy this equation of y equals x plus 1? So let's just pick some values for x. So I made myself a little table here, and I chose 0, 2, and 4. You can choose any values you want for x. And now substitute those values into the equation of y equals x plus 1 to find what their corresponding y values are. So for instance, this first one, when I plug a 0 in, 0 plus 1 is 1. So that 1 is my y value. Same thing with a 3. Oh, sorry, a 2, and you get 3. And so that 3 is the y value. And then you plug in a 4. 4 plus 1 is 5. And so that becomes our y value. And we can write these as ordered pairs. 0, 1, 2, 3, and 4, 5. Okay, so given the equation y equals 3x minus 2, find the ordered pairs for 0, x equals 0, x equals 1, x equals 2, and use these to graph the equation. Okay, so we'll start off making a table. I got my 0, 1, and 2. It looks like I picked the third value, 3. Okay, have our nice grid. Plop a 0 in first, substitute a 0 in first. 3 times 0 minus 2 is negative 2, so that negative 2 goes in for y, and there's our ordered pair 0, negative 2, and we can plot it. You can do the same thing for the other points. Plug in a 1 for x. 3 times 1 minus 2 is 1, and so there's my other ordered pair at 1, 1, and I plot that point. And then you plug a 2 in for x. 3 times 2 minus 2 is 4. Here's your other coordinate, 2, 4. Plot that point. It looks like I did a third point, or a fourth point actually, and I get 3, 7. Once you get those, draw a nice line right through them as best you can. Use a straight edge on these. Okay, given the equation, y equals negative 3x plus 2, complete the table below and write the final points as ordered pairs. So again, there's our table. Plug in your 0. You're going to get a 2. Plug in your 1. You're going to get negative 1. So be careful with your signs on these. And you're going to plot that point. Plug in a 2. You're going to get negative 4. Plug in a 3. You're going to get negative 7. And then draw your line. Let's graph 2x minus 5. Now ultimately, you're not going to be given these values over here. You're just going to select them. 0 is always a good choice. 0 is almost always a good choice. In fact, it's always one good choice for x. And then pick some other number. You definitely need to have at least 2, right? I often will recommend that students choose a third point as a checkpoint just to make sure. So there's our graph. Let's pick negative. When x is 0, we get negative 5. You can plot that point. When x is 1, and again, you can sort of cover that up, right? And you can put the 1 in mentally, maybe. 2 times 1 minus 5 is negative 3. Do the same thing for a 2. You get negative 1. Same thing for a 3. You get 1. And then draw your line. And you'll get quicker at these once you do maybe 5 or 6 of them. It may take more than that. See if you can do this one on your own. I know it's got a fraction, but I'm pretty sure you can do it. Okay, so why did I choose 0, 2, 4, and 6? Why didn't I choose 0, 1, 2, and 3? Well, 0 works out fine, right? When I plug a 0 and I get a 3. But what if I put a 1 in for x? I get a fraction. Nothing wrong with the fractions. They're sometimes a little hard to plot. So I'm going to choose a value that will divide nicely with that 2. So any multiple of 2, 2, 4, 6, 8, or I could choose negative values if I wanted. So I put a 2 in, and what's going to happen? I'll have 1/2 times 2 plus 3. 2's cancel, you get 1 plus 3, and you're going to get a 4. Similar with when you plug a 4 in. Half of 4 is 2, 2 plus 3 is 5. Plug a 6 in, half of 6 is 3, 3 plus 3 is 6. So you've got your nice points there, and draw your line. Example 8. Let's graph 2x plus 5 equals 10. So there are a couple different ways we can do this. At this point, I want you to solve for y. We've had practice doing that in the past, so let's solve that equation for y, and then we'll do the same thing we did in the last problems. Go ahead and pause the video, solve for y on your own. Don't just watch me do it. Okay, welcome back. So solve for y, subtract 2x from both sides, divide through by a 5, and you get negative 2/5 x plus 2. Make your little table. 0 is always a good point, a good coordinate to choose. So when x is 0, we get a 2. And then choose something else. What else do you want to choose? Something that will divide nicely with that 5. How about a 5? So you plug a 5 in, and I'll show you what this looks like. So negative 2/5 times 5 plus 2. Those 5's cancel. Negative 2 plus 2 is 0. So I've got my 2 points. And let's just use 2 points for now, and we draw our line.